Is that working now?
Mm-hmm.
Cool. All right. Let's see. What's up? Oh, okay. Sounds good. So yeah, so what I wanted to do today was cover a little bit about just some of the math and kind of what's going on behind the scenes when we talk about 2D collisions and 2D physics within Unity or really kind of any game engine that we're dealing with. So this image should be burned into your heads by now. This is going over what a game loop should look like. And so as we're iterating over it, when we get into the logic update, that's where we cover how we're going to set the state for the game at that particular moment in time. And so we can think about it in these two terms. So we can think about it in we're doing the simulation within the logic update. So we're figuring out how objects move, what's interacting with one another. And then when we get down to the render, that's where we do the presentation portion of it. So that's what we see on the screen. In our games, we deal with instances where we have images that can overlap each other. And so the way that we handle these pixel overlaps, if you remember from our conversation on 2D graphics, when we get ready to render the scene, we put it into a frame buffer. So the frame buffer is just a 2D array that has all the different pixels that will be represented on your screen. And so in here, there's 4 values that go into each of these squares. Does anyone remember what those 4 values are?
Red, green, blue, white?
Close. What white? Yes. Yes, alpha. So red, green, blue. Those are your primary colors, and then the alpha channel that determines the level of opacity. So for the image that we saw here, we can determine if these objects are more solid or if there's some level of transparency, and based upon that, when we know where these are drawn, we can then figure out how to blend the images together. And so in this case, our robot has a little bit of some of an alpha value, so you get the character's hand kind of behind the ghost. The ghost, yeah. So the robot ghost. But yeah, so when we get in, so really what we're doing with that blending is that we're calculating when we see an overlap. And then once we have that overlap, we have some functionality that we've created to then determine how to handle this type of this instance. And so we can think about, so just kind of frame that in mind, we can take some of that idea and apply it to how objects interact with each other in our environment. So all of you now should be familiar with box colliders and castle colliders in some fashion. And so for here we have a box collider. And really what the box collider is doing is it's drawing just a giant rectangle around your object. And the way that we're doing our collision is we're observing whether or not these 2 boxes are overlapping each other. And if we see an overlap, that's when we know at some point a collision has transpired between the 2, and we should do something at that point in time. So like I said, so we can draw, say, kind of a box. We can also have a collision. So there's the idea of like a polygon collider that goes around the contours of the character. So what would be What's the disadvantage of doing something like that? If you're to have a polygon that perfectly fit your characters to do collision detection. Yes, Simon.
If you and store one animation where both of you are off the ground at the same time, they're gonna kind of sync if both are them.
Yes. So yeah, so you can have it where it uh, may not look accurate. But with regards to just the collision themselves, what would be a disadvantage? So so I guess how would we calculate whether or not these two boxes are colliding with each other? So a kind of an easy way would be to see if x for one point of your square is greater than the x of the other point, and if the y is also uh, here, if the y is then less than the y up here, then we know that their collision is going to happen. So it's a really easy calculation. And so the more complex your shape is, the harder it is to calculate whether or not two pieces of geometry overlap. And so that's why you see a lot of preference for box colliders and circle colliders rather than something that fits tightly around the character. And in fact, you can do tricks if you want finer precision by just taking that simple geometry and just using multiples of it on the character. So for instance, you could have a circle collider that just fits around the head. You could have a box collider that fits around the body, and then maybe a box collider on the feet. So in those cases, you're still using simple geometry, but now you've tightened the bounding around it such that when it interacts with the environment, you don't get a level of error that you would see with just having one big piece of geometry surrounding your character. So the other thing we kind of mentioned in class 2 is the idea of ray casting. And so explain what a bounding box, like a bounding box and bounding collision would be.
No,
The math behind this?
no, just this ray of line intersection.
I'm not sure yet. It wouldn't be. I mean, really, this is to highlight when we talk about a ray cast. What are we talking about with ray cast? So all of you now have experience with a ray cast, or like you're using a ray cast, even though you may not necessarily know it. So when we talk about the aim object, so as we're aiming around in the environment, what we're doing is we're constructing a ray. And so if you remember from your middle school and high school geometry days, a ray is just a point with a line that's going in one direction. And so in this case, we have here Q going off in some direction. So we're looking out to we set Q, and we're putting it on spectrum S. So that's the QS. And so what we're doing here is that based upon the ray cast, we can check to see if we intersect with a particular line. And if it's so, where along that line we intersect. And so when we talk about ray casts, that's really what we're doing is that we're setting off a ray to then check to see what lines that ray may intersect with. At that point, we claim that a collision is transpired. Let's see, I don't really want to talk about inside-outside testing. So this is kind of interesting. So if we're looking at how we actually do these collisions, and so in kind of a algorithmic trick that we use is the idea of kind of quad trees. And really this is an example of a quad tree. So really what you're doing is that you're breaking up the world into different segments. So here, what we can do is we can draw a segment, so from top to bottom, left to right. So now we have 4 quadrants, right? And then I can split that further, so I can split each quadrant into smaller quadrants. So now I have this. And then I can take a square here, split that up, take a square here, split that up. And so, what's the point, what's the purpose of doing something like this? And really is to determine whether or not, one thing that this really becomes beneficial is if you have multiple objects in your environments. Right now, in the worlds that you have, about how many objects? It's probably like about 100 to maybe 150. If you took the example that we have, right? So you have your character, then you have all those tiles, and then all the trees, and all of them can have collision boxes associated with them, right? And so how do you figure, and so when we're running the code, we have to figure out what's colliding with what at any particular time. And so, an easy way to do that would be to say, I'm going to take one object, and I'm going to look at every object that's in my game right now, and see whether or not they're colliding. And so, so for those who are not familiar with computer science, there's this concept of what we call big O notation. And so this really, what you do with that is you characterize how fast an algorithm runs based upon how many inputs you're providing to it. So for instance, if I have, oh shit, this ain't right. Okay. Say I have one big list, right? And let's say I have a number. So it's 1, 2, 3, 4. And I want to see if I have the number 2 somewhere in this list. So, so right now, how many times would I have to go through the array before I find it? If I start at the left and go over.
Just once?
Well, once would be here.
Twice?
Twice, right. And so, well, what if I rearrange these?
4 times?
Right. And so, at worst, it would be the entire list for me to go through before I find the number I'm looking for. And so, doing something like this, just a linear search, we call this an order n operation. So, because I could have, an arbitrarily long array, at worst, it's going to take me, I'd have to look through all the items. So, if n is the number of items in there, it would take me n times to do that. Does that make sense? Yeah. So where am I going with this? So in a game, we have a bunch of objects on our screen. It's kind of hard for some people to see that. I apologize. So I take one item here. I now have to check to see if this is interacting with any of the other objects on the screen. Does that make sense? Okay, so if I have n objects on the screen, for this one, I have to do n minus 1 checks. So I know I'm not colliding with them. This object's not colliding with itself. So it's n minus 1. And then I do that again for another object. It's not n minus 1 checks. Eventually, it becomes an operation that's called n squared. So if you would take, so that characterizes how long it would take for checking if all the objects will interact with each other. And so if you have, say, like some particle effect, where you could have like millions of particles interacting with each other, and now you're trying to see, which particles are actually colliding with each other, that's a huge problem. And so what makes sense is instead of trying to figure out, if this circle here is colliding with everything, what I can do is I can divide the screen, I can divide the space into these different sections. And so now, that's where this idea of this quad tree comes into place. So I'm just dividing the world into these quadrants. And then I can get down to a particular size. And now I just go through each quadrant and I see, okay, I'm in this quadrant here. How many items do I have in this? Like what quadrant, or what's contained in this quadrant? And so right now I just have one item here. I guess I could say 3, these overlap. So now I just have to check these two to see whether or not they're colliding. And then again, I can just go through each quadrant and do a much simpler check. So it just reduces the amount of complexity, reduces the amount of time you need to do your collision checks. So instead of trying to figure out how everything we need to collide with everything in the world, you're just looking at a section of the world, seeing what's in there, and determining what's colliding with each other. It's a cool trick. And so you can kind of do that within Unity right now. So you have, you have this, you play with layers already, but within here you also now have this layer collision matrix. And so you can actually, within the layers you define, you can then say these layers can interact with these other layers. And so you're, in a sense, kind of doing that collision space trick, but now you're doing it with regards to, you can just specify what if I'm going to look at objects on a particular layer, what can they potentially interact with? And then you'll limit the number of checks that you do just to get the objects that are in those particular layers. Like I said, it's really there to help simplify the number of, or reduce kind of the number of collision checks you have to do. And so, as you play with this some more, maybe you can add just a crazy number of objects into your world. You can start experimenting with how your runtime is affected. You can start putting things on different layers and then defining kind of how they interact with each other. So it's fun stuff. So now I'm going to talk about kind of the two ways that Unity looks for or reports collisions. So all of you now have experience with these. So the on collision, well, at least on collision enter. And so on collision enter, what that means is that you have two objects, and the moment that they intersect with each other, that's defined as a collision. So at that event, that's where you get the that call. So on collision stay, what do you think that means, or what event would trigger that?
Saying I'm not going into an object that's staying still.
Yeah. So they collide and they just kind of stay butted up against each other. That's an on collision stay. So you would get an event if you still had two objects that were still in collision with one another.
So, like for example, like a 3D game, you're walking and it's like you're walking and there's a lamppost. There's like a lamppost. You collide with it. Like that. Okay.
Yeah. So if you had the character in the lamppost, so you would get when the character first runs into the lamppost, you get this on collision enter. And if the character just runs into the lamppost, you get this on collision stay. And if they finally walk away from the lamppost,
That's hot.
then you get the
exit.
So those are the three collisions. Triggers are a little different in that what a trigger does is it allows for So you can set up your colliders as triggers. And what a trigger does is it allows for passing through that particular zone. So you all probably heard like trigger zones in games. That's where the term comes from. Is that you can define an area, and if an object intersects with it, instead of trying to apply the physics that would be required to show a collision between the two, you just let that object pass through it. And so with a trigger, you can do things like it's the same type of events. So you have a current in the prior example, maybe instead of being a light pole, it's now a checkpoint for your character. So if your character as soon as they enter the checkpoint, you don't want them to run into, say, that light pole that you have marked as the checkpoint. You just want them to pass through and say, okay, they've made it to this point, so let's save that point so if they die, we restart them at that spawn point. So you'd have the trigger enter, so when they go through it, you get that event. If they linger in that, you can have the stay event, and then as soon as they pass through it, then you have the trigger exit. So let's say you can use triggers. So triggers are used for just detecting when objects enter a particular area. And so like I said, you can do them for checkpoints, or I think Danae was interested about if you pass through platforms. So if you jump through a platform, that platform can be a trigger. But then as soon as they exit that, they go through and exit it, you now turn that trigger flag off and turn it back into a collision. And so then when they come back down, the collider is now back enabled, and it's treated like a normal collider. So, let's see. So this gets into a little bit more of the weeds of, I really don't want to belabor this point. If you really want to understand, so if you look through the rigid bodies and the various colliders, how they interact with each other, you can look at this chart to give you a little more information, but don't want to belabor it. Don't really want to get into that too much. Let's talk a little bit about physics, because all of you also have some experience in physics now. So your characters, they're now being moved using the rigid body system in Unity. So the way that the way we move things with the rigid body is that we apply a force to it to then move it through the world. And so, for those who have taken a physics class, there shouldn't be too, they should be familiar. For those who haven't, this represents kind of Newton's first law of physics. So really what I'm calculating here is I have some initial point. So this is kind of where the object starts. And then I can apply a velocity to it. So this v init is the initial velocity. So if I calculate t plus some t init, so the current time and some time in the future, and then I add in the gravitational force. So the gravity is going to be adding a gravity vector to this. Then I can tell you, so I keep these constant, then I can tell you at any point in time t where the object will be along that curve. And that's really kind of, so like I said, when we're using the rigid bodies, in a sense, we're really kind of applying the same idea with Newton's first law, or really kind of any Newton's law, is that we're applying a vector, we're applying a velocity vector to an object, and then we're predicting, and then being able to see where it ends up at at some point in time. So this is now we're really getting into some kind of serious math. So if you were to expand this out, if you wanted to expand this out and look at every moment in time, no, it will not be on the quiz. But this is so if you're wanting to do kind of the expansion, so this is the representation of looking at every moment in time, what that force would be. And so the reason I bring that up, let's skip ahead here. So really, when we talk about the kind of theoretical ideas of physics, we talk about this ideal world, and so we can look at an exact moment in time and know when a collision happens, and then be able to react to it. Because we're dealing with a simulation environment, we don't deal with continuous time, right? Because we're doing this loop. So every time we loop, we're kind of advancing time just by a little increment. So if we have, say, two objects moving, if time was precisely calculated, you just see them just run into each other, no problem. But because we're dealing with a simulated environment and we're incrementing the world by time steps, we're really just kind of moving things at kind of these slow increments. And so if your increments are too large, then you may have instances where you have two objects that essentially kind of pass through each other. And that becomes problem. And then it becomes really problematic if you have something like this.
Right into each other.
Yeah, where you've calculated it such that now one object is absorbed with the other object.
I've seen that sometimes when you're moving a character and you stop and you have to continue with you, because it goes through you. Practical sometimes just sticks in you, but there's no problem.
Right.
There.
So going back to our
not again.
Going back to our Newton's first law, so this is kind of the perfect solution. Like I said, we're dealing with this world that advances in these kind of chunky time increments. And so because of that, our numerical solution looks more like this, where we have some starting point, we apply a velocity, some change in time, and then we have a little bit of error that we put out there. And so this error will end up varying based upon how complex your forces are with one another. So if you have two objects colliding, that's not too complicated. But if you're dealing with forces, such as if you have an object that has several hinges and joints tied to one another, and now you're trying to calculate if I push an object, how are all those hinges and joints going to move and operate? Now you're trying to deal with the possibility of running into larger and larger errors with your calculation.
So all these calculation things are not going to be on the test?
No.
Like even that Newton Laws one?
No, Newton Laws will not be on the test.
It will?
It will not.
Okay.
And so the way we get around doing some of this stuff is that we apply these kind of dampening forces. And so the dampening forces, what they're there to do is to help constrain how far these things are going to move in air, such that we bound the movement so it's not too complex. And so within your within your rigid body, you have things like the linear drag, the angular drag. And all those are there to help kind of add that dampening force to prevent, really to accommodate for that error that you will get in your calculations. And again, it's one of those things where you really can't calculate or figure it out until you actually start seeing it in motion. And then once you start seeing it, you can start playing some of these values to then counteract the forces that you have going on in your environment. But okay, so taking that all in mind, let's switch back to the assignment so we can see how this stuff kind of applies to our assignment.
So I'm assuming that player input, logic update, and renders are going to be on his the pixel overlap, bounding box check, and the collision space and real collision code are probably going to be on there.
I'd say probably talking about, question probably about bounding boxes would be on there. Question about raycasts.
That radio line.
Yeah. And probably maybe a question about the collision spaces.
So,
like what collision spaces are.
Collision code. The real collision code.
No, the collision spaces.
Alright, those are the ones.
With respect to collisions, yes. Okay. Yeah, so we go back and we look at, say, our destroyable code. So if you remember our destroyable code, actually destroyable is not a good one to look at because really we're not, where that collision happens, come back to use equipment. Oh, shoot, I need to stop. Okay, so now we're back on, okay, so now we're looking at the use equipment. So we talked about this idea of raycasts. And so here, I said you are using raycasts in the sense that I'd start with a point, which is where the character is, and the direction now being the character to that aim object. So it's drawing an array, and you can think it, and you can kind of envision in your head what it looks like from that character to wherever that aim object is. And so when that ray ends up going through a layer that you define as a target, at that point, then it comes back and says, hey, I hit something. And then you can check to see what was the first thing it hit with that raycast. So here's where we're using that raycast within our game. And then with regards, and so kind of the thing we need to do now, so if I run the game, just kind of recap kind of where we left off. So I have my character, so I do the raycast and it hits a target. And if I start breaking things, so now say I'm making these kind of dirt blocks. And these are the things like I want to be able to pick these things up. So this is kind of the next part of our assignment is being able to turn these into items that we can grab and be able to use. And so in the assignment, so you've been provided this pickup script for you to work on. I'm going to open that up, and you can see we're using the on-collision enter 2D to look for the event where the item that's being picked up is colliding with a particular object. And so So I stubbed out kind of what we need to do in this. And so here I'm saying get the use equipment component from player. And then we're going to call use equipment to set it as the item. And then we'll remove the item from the scene. So, yeah, and so the reason that we're doing, well, I guess we probably just jump into this and start working on it. So if you remember, kind of the way that we get components off an object is that we can use this get component function that's tied to a game object. So here, I'm going to say, and so you can specify the variable, or I'm sorry, the data type. So you can say use equipment, and then we can give it a name. So I'll just call it equipment, or just equip. And I can look at, so collision, this is the item that our pickup is colliding with. And I want the game object tied to that. And I can say get component, use equipment. And then what really matters here is I want to see whether or not this is null. And so the reason being is that this call is going to happen whenever the pickup item collides with anything. So the pickup item may collide with the player character, but it's also colliding with the other tiles. Like when I was kicking it around, it's touching all these other items that have collision boxes on them. So this is always going to get called when it collides with anything. And so really what I want to do is to verify that what I'm colliding with is the player, because the player is the only object out there that has this use equipment component. So that ends up being the check to see whether or not we're colliding with the right thing. So here, so I say equip, set current equipment, and now it wants the game object. And so one thing I've noticed that I'm missing here that I need to add, I'm going to go ahead and add this, is an item to be associated with the pickup object. And I'll explain why in a bit. I'm going to go ahead, set this to item. Oops. And then I'm going to remove the pickup from the scene. So here, I'm just going to destroy the game object. So I'm going to destroy the item that we just picked up. I'm going to save this. Go back to make sure this compiles okay. Excellent. Okay, so if I go, and so what I'm going to do now, I'm going to create a pickup item. Well, we already have a pickup item. We have the mud block. But now I need to add that pickup script to it. And I want to add an item. And then the reason I'm differentiating between these two is that if I were to make the item that we pick up, if we make the item that we pick up the actual game item itself, then what would happen is we would destroy the original object. And then if we destroy that, then this would end up being nullified, so we wouldn't be able to see it. And so, just for simplicity's sake, right now, I'll break it up in two. I can show you how to modify this. So, if you want to have your pickup item be the same, be the item that gets passed here, how to do something like that. But at any rate, I'm going to move ahead. And so I'm going to make a pickup item. So I get this mud block. I'm going to create a new object out here. And I'm just going to call it Apple. So I'm just going to show an item that you can use with the pickup. So I say sprite. So I'm going to add sprite renderer. Take one of these Apple images. That one looks good. I'm going to go ahead and move that into here. So now it's a prefab. And so what I've done for the assignment, if I go back to use equipment, so in the assignment, what happens is that if you right click, then you call this use item, and it passes the position of the game object. And then here, what use item does, it sees whether or not you pick something up. So is current item not equal to null? And if that's the case, then what it does is it grabs an item component, make sure the item component is on the item you want to use, and then calls it its use function. And so this goes into the ideas of object-oriented programming, and it goes into something a little bit different that we didn't really talk a whole lot about object-oriented programming. This is idea of what's called polymorphism. So really the idea is that you can specify a method, or really you can specify a method, and you can have it implemented in different ways. And so based upon the how each object implements it, like that's what is run. But we don't have to tell exactly, or in the code here, we go back to the use item or use equipment. So here, all we have to say is say, I'm going to call the use method that's tied to some item. I don't care what item it is, but I know an item has a use method, so call that use method. And right now I've defined one for you. So I have this use method here. And really what this is doing is that it's allowing you to place an object wherever your reticle is pointed at. And so it's doing some calculation here to see whether or not you're pointing something on the ground. You're pointing on the ground. And if you are, then it goes ahead and ends up creating the item and placing it down on the ground for you. So, so I said that what's cool about this, or what we can do with this, is now we can define multiple behaviors for items. So we could have something like throw item, where instead of for use, we can put in some functionality that then allows you to then just throw the object rather than just kind of place it down on the ground. Or the use would be, it's something where it interacts with the player. So if I say I want to use this power up, like make my character bigger or make it faster, anything like that, you can now apply it to here. And so I'll provide an example on how to do this. So if you want to kind of take that forward, you have the ability to do that. For this assignment, we're just looking at just creating a prefab that let's say it serves as our item that we can use. And so here, I'm going to call place item. And so in place item, it needs a grid offset and a grid size. So right now our grid size, I believe, is 0.32 and 0.32. And then the placeable layers, so where you place things in the world. So right now we'll just be able to say we're going to place things on the ground. And so now if I come back to mud block, so now I just say, what is the item that I can use if I pick this up? I can now use an apple. And so I'm going to start playing.
Or the apple.
So I break these apart.
Whoa.
I haven't fully broken that one yet. Alright, so now I can pick things up. Whoop, my apple is nowhere to be seen.
Oh.
Oh, it's just hidden. And it's on the wrong layer. There we go.
There it is.
So to go back and so to fix that, we just go back to the prefab, set the foreground, an apple. So now make sure this works. Breaking things, pick it up, and if I right click, so right now it's not going to, because the place is only going to look for whenever I'm interacting with the ground. It's only going to place it once I'm on the ground. And now I have this cute little apple that's sitting there. I guess I could give it I left off some stuff, so I could give it a box collider. I could give it a rigid body so I can kick it around.
Apple sucker.
There you go. Push it around. Yay. Alright. Cool. So let's see if we can simplify our pickup script a little bit more. So you go back to our pickup script. So right now, what I'm trying to do is I'm making this distinct object. And maybe what I want to do is have my pickup object be the same thing as what I want to use. So instead of destroying the object, what you can do is you can disable the game object. So if I said game object, so the set active. So if you go back to Unity, so this checkbox up here, that tells you whether or not an object is active in the world or not. And so if it's inactive, what happens is that it just ignores any of the callbacks that Unity provides. So it won't receive any updates. It won't receive any notifications with regards to collisions or anything like that. In a sense, like the object is still in the world, it's just no longer interacting with it. And because it ends up being disabled, you wouldn't see like a sprite render or anything like that. So what we can do is we can say, effectively, we'll just disable it. And then what we can do is that when we want to use it, at that point we can re-enable it, or let's see, if I modify our place object, what would that do? So here, what I'll do now, change this. So instead of an item, I'm going to pass it the game object. In fact, let me do this just for the sake of just keeping around. We know it already works. So I'm just going to copy and comment out that line. So I'm going to pass in the game. So I'm just going to pass it the game object. I'm going to disable the game object. And then in place item, so what we do in place item is right now we're making a new copy of that game object and putting it out in the world. And so we could do that, and then we would just destroy the old copy because we don't want to keep multiple copies of it around. Now if I go back to Unity, and so right now the mud block, and so what should happen now is, if I click on mud block, because now I can make my mud block one the same, so I can make that the place item. And set this to ground. And let's see if this works. So if it works, what I should see now, so here I break it apart, and now you can see it's gone away. But if you look up here, I still have my mud block. It hasn't been destroyed. It's just hidden. So it's no longer interacting with the world. But now if I place... Ah, nuts. Why did I do that?
Wrong button.
Let's double check. Did I not save? That's right, I didn't save it. So,
Whoopsie.
let's try this again.
Always save.
That's right. So let's try this again. Okay, so now I got that. Oops.
Forgot to move it forward.
So you can see now I have this clone sitting there.
It's a clone of a clone.
And the problem is I just forgot to re-enable it. So what I need to do in the script is I come back here. So my pickup script, or my place item script, sorry. So game object, new item. And new item. Because what happened was that this game object, because we saved its state as inactive, when I made a new version of it, it kept that state. So I did. So that's why you saw it as being inactive. But now I'm just going to re-enable it and then destroy. So keep the copy and then destroy the original. So let's try this one more time. Okay, and then I drop, and hooray, I have a mud block. And now I can pick it up and I can put it down again. I can do it again. So, and right now it's saved such that anytime you use, oh no, that's right. So you can only be able to use it once if you do it that way.
Which you forgot to put on the thing about moving it.
The
rigid body if you wanted to do that.
Say it again?
Nothing.
Okay. So, yes, right now you just essentially pick up and put back down what you already have there. So, like I said, so that allows you to just kind of combine all the items you need. So you can either kind of break it apart into two, or just have everything within one. So the item, essentially pick up is the item that you're going to use. I said once we get into the inventory system, you can see why that may or may not be advantageous to you to do that. Yes.
So if we want to be able to break like multiple things, like break the ground and break the trees, so like the ground gives us dirt and the trees gives us wood, we run the same script but just put different prefabs inside Unity, right?
Yep. So yeah. So let me demonstrate that. So here, so let's see the tree. The tied to. Looks like, which prefab is that? Looks like this one.
No, it's the other one. Maybe.
That's 4 sheet 15.
No, it's that one since the tree is on higher. And you see more of the bark than the other one.
So that one?
Yeah.
Okay. So, yeah, so let's go through. So, say I want to be able to break this apart. So, I'd mark this, so I give it the destroyable. I would need to mark this as something that we can destroy. So, I don't want to say it's ground, because it's not. Let's call it loot. And then.
Every tree is a loot.
And then here, I can set the prefabs I want to pick up. So I'll say 1. And right now, I'll just make it the mud block again. Because we have this quarter damage and half damage,
3/4 damage.
3/4 damage. So right now, just to let's see, because I need to give it some imagery. So I'll just turn it into a weird shrub when you collide with it. So make it a weird shrub, make it a baby shrub, make it a little piece of grass, stuff like that, and then apply. And then if I come to my character, I just have to make sure that my target layers are now both the ground and the loot. And so if I go play, so now you can see my reticle now runs into this. So if I click on it, whoops, goes apart. I did not produce anything. Hit points. So turn that down to like 40. Let's try this again. And then Interesting. I don't know why it didn't. Where is the tree? Huh. Foreground center.
Maybe since you have it under loop, maybe? Tag layer for loop.
Well, having on that tag layer, that should allow for the interact. So that's allowing for the interaction, which that's what we want. It's just now the character doesn't seem it's wanting to
destroy it.
Well, destroys.
Oh, probably because you don't have the other ones put forward. You have the cursor still there.
Oh, I see what you're saying. Yeah,
the image in the background.
That's right.
That's why.
Okay.
So you need to bring them forward.
I should just change. Huh. Well, yeah, they would just be modifying, but you get the gist. That's, so you can select different objects. The things you want to break apart, put the destroyable script on it, and then for items you want to pick up, put that pickup script on. And then if you want, let's say you have kind of different ways you can handle the items you can use. You can make your pickup item the same as the use item, or if you want to break it apart into two. And I showed you kind of both ways how to do that. But yeah, that covers kind of everything you need for the assignment. So Tuesday we'll do our quiz, and it'll be kind of a catch-up day. So if you have questions, that's a good time to ask them. But yeah, we'll handle Tuesday like that, and then no class the following Thursday for fall break.
So nobody show up here.
That's right. So nobody will be here. All right, well, that's it for today. So I'll see you all on Tuesday.